Hi everyone, so in this video we are going to be talking about matrices and row operations. So to start off, matrices. So a matrix is a rectangular array of numbers. An m by n matrix has m rows and n columns, called the dimensions or the size of the matrix. So these first four examples are all examples of matrices. So as you can see, they have rows and they have columns. So these are rows, these are columns. Right? The things inside of the matrix are called elements. Right? So each number is an element. Right? So for these first ones, we're just going to be talking about the size and figuring out the size of each of these. So for example 1, since it has 2 rows and 2 columns, we say its size is 2 by 2. For example 2, this one has 1, 2, 3, 4 rows. And in this case, it just has 1 column. So we would call that a 4 by 1 matrix. The next one, 1, 2, 3 rows. And 1, 2 columns. So 3 by 2. And the last one, it has 1 row and 2 columns. All right, now if we ever wanted to actually talk about exactly one of these elements, all we'd have to do is say what row it's in and then what column it's in. And that would tell us the element. So for example, if we go back to this example 3 right here, if we wanted to know what was in row 2, column 1, we would just look at row 2, column 1, and that would be the 12th. So if we're ever trying to talk about an element, we're just going to say what row it's in and what column it's in. Okay. Next up is going to be writing a system as an augmented matrix. So this is going to lead into what we're going to be doing in the next set of notes. Is we're going to actually be trying to solve systems using a matrix. So we've already learned a couple ways to solve a system. This is going to be another way to solve a system as a matrix. All right, so an augmented matrix is just the system without the variables and without the equals. That's essentially all it is. So you just take the number in front of x, that goes first. The number in front of y goes in the next spot. The number in front of z, if there's nothing there, remember that's a hidden 1. So that's 1. Where the equals is, that's where we put a line in our augmented matrix. And the numbers on the right go to the right of that line. All right. Now it is important that in order to set up as an augmented matrix, make sure that your variables are in order. So make sure it's x, y, and z, not something like zyx or anything like that. Also make sure that they're on one side of the equation. You don't want some of these variables on the other side or anything like that, because then you're going to get different stuff. All right, from there, you just do it again for each of these equations and make a new row for each one. So again, 2, then hidden 1, another hidden 1, but this time it's negative, so it's going to be -1. And then the number on the other side is 4. For the last one, same exact thing. We have 10, 2, 1/2, and 1. And that's it. And in the end, what you end up with is 3 rows, each representing a different equation in the original system. So this comes from equation 1, equation 2, equation 3. And the columns represent what was in those equations, as in like what variable. So this first one represents the coefficients in all the x's. Second one represents the coefficients on all the y's. Then all the z's. And then all the constants, so the ones without any variable with them. All right, let's go ahead and look at another one. So again, we start with the number in front of x, so that's 5. Number in front of y is -1/2. Then the number on the end is 4. For the second one, if you notice, there's something missing. There's no x there. So if x is completely missing, we put a 0 because there's no x's in that equation. Then continue like normal. So 1y and 8 on the end. All right, let's go ahead and try one now. So example 3. We're going to go ahead and do this one ourselves instead of it being given for us. So again, just write the numbers in front of the variables. So it would be 1x, so 1, -1y, -1, 1z, 1, and there's a 7 on the other side. For the next one, be careful. We don't want to start with 2 because we always start with x, but in this one the x is missing. So we're going to put 0 because there's no x's. There's 2 y's, -3 z's, and then -13 is the number on the other side. All right, last row. Go ahead and give it a shot real quick. I will pop up the answer in just a second, but it's just like doing the second row. All right, and here is the answer. Is 3, 0, -2, -3. Only thing to make sure you were careful on was it is a 0 right there because the y's were missing. So we put a 0 for that missing y. All right, the next piece that we need to learn about is matrix row operations. So row operations are different things we can do to a matrix to manipulate it that doesn't actually change the system. Right? So there's going to be 3 different things that we can do. Right? So this first one, I usually like to call swap. You can literally just swap any 2 rows. This double-sided arrow is your indication that it's swap. Right? So in this case, it just means swap row 1 with row 2. So whatever row 1 had in it, in our new matrix, that's going to be what row 2 is. And whatever row 2 had in it, in our new matrix, that's going to be what row 1 is. So in our new matrix, row 1 is 1, -2, -3, 4, and row 2 is 2, -4, 5, -3, because we're just swapping those two rows. Notice that we did not do anything to row 3, because this was just swap rows 1 and 2. It tells you which ones to swap. We didn't have to swap row 3, so it stays the exact same. Next one, I like to call multiply or divide. So you can multiply or divide any row by a non-zero scalar. You can't do it by 0, because if you multiply a whole row by 0, well then all of those numbers just go away. They all turn into zeros. That's no help. So we can never multiply by 0, but you can multiply it by anything else. And by extension, you can divide it by anything you want as well, as long as you're not dividing by 0 either. All right, so again, another example. If we have this matrix on the left, and we want to do -1/4 times row 2 will replace row 2. All we're going to do is we're going to multiply every single number in row 2 by -1/4. So 0 times -1/4 is 0. -1/4 times -4 gets us 1. -1/4 times 8 is -2. And -1/4 times 24 is -6. Okay. Now, this last little part, that literally says replaces row 2. So what that means is that your answer of multiplying that row is going to go where row 2 used to be. So row 1 stays the same. Notice row 1 did not change whatsoever. Same thing with row 3. Stayed the exact same. The only thing that actually changed was row 2. All right, third one. The third one I like to call combination, just because you can combine two rows together by multiplying a row by some non-zero scalar again, and then adding it to another row. Right? So here's what I mean by that. If we have our matrix on the left, then 6 row 2 plus row 3 replaces row 3 as the actual operation that we're going to try to do. All right? Now, remember, the replaces row 3 just tells us where we are going to put our answer. So before we even do any kind of operation, just keep in mind row 1, row 2 are staying the exact same. We do not change them at all. All right, now this is the one that I do recommend doing some scratch work out to the side for. So 6 row 2 plus row 3. That's what we're trying to do. And that's going to replace row 3. So first off, let's do 6 times row 2. So 6 times 0 would be 0. 6 times 1 is 6. 6 times -2 is -12. And 6 times -6 is -36. Plus row 3. So let's write row 3 exactly how it is. So 0, -6, 4, -7. Now it says to add those. So all we're going to do is go down each column and add them. So 0 plus 0 is 0. 6 minus 6 is 0. Negative 12 plus 4 is negative 8. And negative 36 minus 7 is negative 43. And we said that that's going to replace our row 3. So this answer that we got is what we put as our new row 3. And that's our total answer. That's our new matrix. All right? Just remember that this up here, where we did 6 times row 2, that was just an in-between step. We don't actually replace row 2 with that. In fact, it doesn't show up in our final matrix at all. It was just an in-between step. So make sure that you just keep that off to the side in your scratch work. It's just this one down here that we actually want to put in our answer. All right, now one more thing that I am going to throw in here, just because it's going to help us in a little bit. It doesn't have to make sense quite yet, but I will refer back to it later. So to go ahead and put in your notes that swap and multiply/divide are to make ones, and combination is to make zeros. Again, you don't have to know what that means yet, but I will be referring back to that later, so just make sure you put that down now. All right, so let's go ahead and go through and try some examples of these different operations. So perform the following row operation for the given augmented matrix. So for example 4, we have a 2 by 3 matrix, so a little smaller, starting easier. And we're going to do 1/4 row 1 replaces row 1. All right, so remember, for the multiplication one, it just means that you multiply everything in that row by that number. So we're going to multiply all of these by 1/4. So 1/4 times 4 is 1. 1/4 times 8 is 2. 1/4 times negative 16 is negative 4. So we replaced row 1, and it doesn't say anything about row 2. So row 2 is staying the exact same. We don't mess with it at all. And that's our answer. All right, example 5. So this time we're going to do the combination one. We are actually going to do it on the matrix that we just got. If you notice, this and this are the exact same. But we're going to be doing -2 row 1 plus row 2 will replace row 2. All right, now again, as soon as you see this, I really do recommend you going off to the side and doing some scratch work. So -2 row 1 plus row 2. That's what we want to do. So -2 times row 1 is going to be -2, -4, +8. We're just multiplying all of row 1 by -2 there. Next, plus row 2. So row 2 is 2, -3, 7. And then we're just going to add them up. So we got 0, -7, 15. And that is going to be replacing row 2. So we're going to rewrite our matrix. Row 1 stays exactly the same, not going to change it at all. But row 2 is our new one, so 0, -7, and 15. And then we're done. All right, next one's going to be a little different. This one we're going to do multiple row operations on this matrix. Now we're going to go in order, so we're going to do this first one. And with that answer, we're going to perform the second one on that. Then with that answer, we're going to do the third one and so on. So we're going to use our answer from the previous one to do parts A, B, C, and D. So let's go ahead and start off with A. So A is swap, which is a nice and easy one. So to swap, we are just going to take what was in row 2 and we're going to replace row 1 with it. We're going to take what was in row 1 and we're going to replace row 2 with it. So our new row 1 is just going to be row 2. 1, -1, 3, 8. Our new row 2 is going to be what row 1 was. 3, 1, -3, 4. And then row 3 we haven't touched at all. So 2, 4, 8, -4. All right, now using that matrix, we're going to do part B. So it's going to be -3, row 1, plus row 2 will replace row 2. So again, I'm going to start this with some scratch work. Off to the side, I'm going to do -3, row 1, plus row 2. And it's going to replace row 2. So -3 times row 1 is going to be -3, +3, -9, -24. Row 2 exactly how it is 3, 1, -3, 4. And then we add up each column. So -3 plus 3 is 0. 3 plus 1 is 4. -9 minus 3 is -12. And -24 plus 4 is -20. That's our new row 2. So whenever we rewrite our matrix, row 1 didn't change because we're not replacing that. So 1, -1, 3, 8. Row 2 we did replace. So that's going to be our new one of 0, 4, -12, -20. Then row 3 didn't change either. 2, 4, 8, -4. All right, let's move on to part C. Remember, we're going to use the one from part B to do part C. So again, this is another combination one. So we're going to start off by going off to the side. We want -2, row 1, plus row 3 will replace row 3. So -2 times row 1 is -2, +2, -6, -16. Row 3 exactly how it is 2, 4, 8, -4. And then we add up the columns. So 0, 6, 2, -20. All right, so let's go ahead and write our new matrix. So rows 1 and 2 did not change. So for the first 2 rows, I'm just going to be copying those down. For the third row, though, we're going to use our new one that we just got. So our new row 3 is 0, 6, 2, negative 20. All right, last one. Again, using the same idea of using the last answer as our starting point, we're going to do 1/4, row 2 will replace row 2. Again, anytime you see this one, it's nice and easy because all you have to do is multiply row 2, all of them by 1/4. So we're going to get 1, negative 1, 3, 8, because we're not messing with row 1 at all. For row 2, 0 times a fourth is 0. 4 times a fourth is 1. Negative 12 times a fourth is negative 3. And negative 20 times a fourth is negative 5. Then we're going to write row 3 just like we had it again. So 0, 6, 2, negative 20. And then we're done with this example of trying to go through and do a few of them in a row. All right. Now, before we go on to the next part, there is something that I want to point out in all of these examples. Right? So in this first one, we did a multiplication. Now, if you remember that thing that I told you to write down that we'll come back to, here's where we're going to start to come back to it just a little bit. I said that multiplication was to make a 1. And we didn't realize it, but that's exactly what we did. We actually made a 1 right there. And the way we did that was we had a 4 there, and so we multiplied it by 1/4. Or you can think of it as dividing by 4. Because any number divided by itself is just 1. So if we wanted to turn that 4 into a 1, we just divided it by 4. Divide it by itself. For example 5, we did a combination. And I said that that was to make zeros. Well, again, that's exactly what we did. So we needed a 0 right there where there was a 2. Well, how do we get rid of a 2? We can subtract 2 from it. Because remember, we can't multiply the whole row by 0. That's a no-no. But we can subtract 2 as long as it's part of a row operation. As in, we can't just subtract 2 from everything on that row. That doesn't quite work. But if we take negative 2 and multiply it by row 1, well, in row 1, we have a 1 right there, and so that doesn't change our negative 2. It's still a negative 2, as you can see right here. That got us our negative 2, which we added to our positive 2, and it got us 0. So we're just adding the opposite. So if it's 2, we added a negative 2. If it was positive 5, we'd add a negative 5. If it was negative 10, we would add 10. That's the idea. For these next ones, for part A, we did a swap, and we ended up with a 1 right here. Then we did 2 combinations in a row, each of those getting another 0. And then we did a multiplication, which got us a 1 again. Now, you don't have to know yet why I'm getting 1s and 0s here, but I did just want to point out that those 1s and 0s are appearing. And to go along with that, the 3 final questions in this notes is going to be how we could make some ones and zeros. All right, so to start off, what row operation will result in a 0 in row 2, column 1? So first off, row 2, column 1 is this 5 right here. That's the one that we would be trying to turn into a 0. All right, now if we want to make a 0, remember we only have one option. Our only option to make a 0 is to use a combination. All right, now here's the formula for it. So we want the opposite number as in, if we have a 5 right there, -5 would be the opposite number, times the row where your 1 is. So what I mean by that is we have a 1 up here in row 1. That's the 1 that we need to use. So our 1 is in row 1. Plus the row where you want the 0. So plus, we want the 0 in row 2. So we're going to put row 2 here. And that will replace the same row as that last one we just did. So it's going to replace row 2, as in these last two should always match. And that's how we make a row operation to get a 0. So opposite of the number that's already there, times the row where you have a 1 in that column, plus the row where you want the 0, will replace that same exact row. All right, let's try that again. So what row operation will result in a 0 in row 3, column 1? So if we want a 0 in row 3, column 1, that means we're looking at that 9 right there. So if we just follow this same formula, we first want the opposite number. So if we have a positive 9, we want -9. Times the row where your 1 is. Our 1 is up here in row 1. So we're going to say row 1. Plus the row where you want the 0. That 9 is currently in row 3. That's where we want the 0. So row 3. And then we'll replace that same row. So row 3 again. And again, if you try either one of those two operations, you should see that you do get zeros in both of those places. All right, last one. Instead of a 0, what operation will result in a 1 in row 2, column 2? All right, so row 2, column 2 is that -4 right there. So if we want a 1, then the idea for getting 1s is we can either swap or do multiplication/division. All right. Well, if we swapped with any row, we wouldn't get a 1, because if we swap these two, a 2 would end up being there. Or if we swapped the last two, A -8 would end up being there. That's not a 1. So swap is completely out, right? But we can use the multiplication / division. So again, to turn anything into a 1, you can always just divide it by itself. So, for example, if we had a 5 and wanted to turn it into a 1, we could divide it by 5. If we had a -10 and wanted to turn it into a 1, we could divide it by -10. It's the same thought process that we use to cancel stuff out when we're solving equations. All right, so if we want to turn this -4 into a 1, then essentially we just need to divide it by -4. Now, there's 2 ways that you can write this. We can say that we want row 2. Keep in mind, I'm putting row 2 because that's where the -4 is. So we can say row 2 divided by -4. We'll replace row 2. Or the other way to write it is as multiplication instead of division. So dividing by -4 is the same exact thing as multiplying by -1/4. If you can see, I kind of just put a 1 here and took the -1/4 outside. So that -1/4 is still there even when you're dividing. But if we do -1/4 times row 2, oops, sorry, not plus, replaces row 2, that is the exact same thing. So whichever one you want to do is perfectly fine. All right, as long as you know to do one of these two. Either way, the idea is to cancel out the -4 to turn it into a 1 by dividing by itself or multiplying by 1 over itself or its reciprocal. All right, with that said, I'm sorry that this one video kind of went a little longer, but hopefully this gives you an idea of what matrices are, just basically a collection of numbers that are arranged into rows and columns, and it's just going to make things a little easier to work with because we don't have to worry about x's and y's and z's. We get to just focus in on the numbers. In the next video, I'm going to be showing a little bit about how to take these row operations and actually solve systems with it. So with all of that said, I will see you in the next video. Thank you.